Good evening, one and all. Today we discuss about switched reluctance motor. Switched reluctance motor is electromagnetic and electrodynamic equipment which converts the electrical energy into mechanical energy. The electromagnetic torque is produced on variable reluctance principle. SRM makes use of power semiconductor switching circuitry and rotor position sensor. SRM is singly excited and doubly salient electrical motor. This means that it has salient poles on both the rotor and the stator, but the only one member carries winding. The rotor has no windings, magnets and catch windings, but it is built from a stack of salient pole laminations. The SRM construction is very simple and robust. It requires less maintenance. Its overall efficiency is better. It is flexible control driving motor as motoring mode and generating mode of operation of the machine can be easily achieved. Now let us see about the construction of SRM. The stator is made up of silicon steel stampings with inward projected poles. The number of poles of the stator can be either an even number or an odd number. All these poles carry field coils. The field coils of opposite poles are connected in series such that their MMFs are additive and they are called phase windings. Individual coil or a group of coils constitute phase windings. Each of the phase windings are connected to the terminal of the motor. These terminals are suitably connected to the output terminals of the power semiconductor switching circuitry, whose input is a DC supply. Now the rotor is also made up of silicon steel stampings with outward projector poles. Number of poles of rotor is different from the number of poles of the stator. The rotor shaft carries a rotor position sensor. The turning on and turning off operation of the various devices of the power semiconductor circuitry are influenced by the signals obtained from the rotor position sensor. Let us see about the block diagram of SRM. The figure shows the block diagram of SRM. DC supply is given to the power semiconductor switching circuitry, which is connected to the various phase windings of switched reluctance motor. The rotor position sensor, which is mounted on the shaft of the SRM, provides signals to the controller output about the position of the rotor with reference to reference axis. The controller collects the information and also reference speed signal and suitably turns on and off the concerned power semiconductor device to the DC supply. The current signal is also feedback to the controller to limit the current within permissible limits. Now we discuss about the principle of operation of SRM. The reluctance torque is produced when a stator phase is excited by means of unidirectional currents. This results in the magnetic direction of attraction of the adjacent rotor poles as it tends to align into a position of minimum reluctance. When the number of stator and rotor poles differ, the sequential switching of the excitation from one set of stator poles to the next in synchronism with the rotor position. It produces an almost constant torque resulting in an uniform rotation of the rotor. The synchronization of the switching on the excitation with rotor position can be accomplished with a simple rotor position feedback. The rotor equation of the switched reluctance motor is T equal to 1 by 2 I square dl by d theta, where I is the instantaneous current in the exciting winding and L is the self-inductance. The torque developed is independent of the direction of the current flow in the windings, so that unidirectional currents can be used to control the motor. The direction of the rotation can be reversed by exciting the phases in the reverse sequence. Now let us see about the modes of operation of the SRM. These are two distinct modes of operation corresponding to low or high speed monitoring of exciting current during low speed operation is essential because of long duration of each phase period and needs chopping of energy station to restrict each phase current within the semiconductor ratings. The developed torque is controlled by varying the average current. Hence, accurate monitoring of the exciting current is required. Obtaining high degrees of controllability is possible. During high speed operation, current control is not essential because the inductance of the winding and motional back EMF induced restrict the excitation to single pulses of current. The torque is controlled by optimal positioning of these pulses rather than the control level. The uses of SRM motor, it is used in washing machine, fans and etc. With this I conclude the basic concepts and operation of SRM. Thank you.